Okay, there's one other thing I want to talk about with stats and graphs, basically. So if you want to show comparison of categorical data like green M&Ms, red M&Ms, blue M&Ms, red, green, blue, and maybe their frequency over here, like maybe 10 and then 20 and then 30, then you'd use a bar graph. Remember, if you have kind of number ranges that once you're out of one, you go into the next, right? So maybe this is 10 to 19, so the next one would be 20 to 29, and then 30 to 39, and 40 to 49. If you're showing like once you're out of this range, you go to this, and again, this is frequency, that would be a histogram, and these would have titles and titles, okay? But another type of graph is when you want to compare numeric things and you think there's a relationship between them. So you kind of have this X and Y, and maybe this is like hours studied for a test, and then maybe this is the test grade. And you're looking and you think, maybe the more I study, maybe my test grade will get better. So say someone studies 0 hours, they get a 50. Someone studies 2 hours, they get a 65. Maybe someone else studies 2 hours and get a 75. 3 hours, and maybe they get an 88. And someone else studied 3 hours and they got, maybe they got a 79. And someone else studied 3 hours and they got a 85, and maybe someone studied 4 hours and got a 98 or something like that, okay? And so we can graph this. Now, when you graph it, we have no negatives, so quadrant 1 is good enough. Make sure your X is always here. It's ID, independent, dependent. So if you think of your ID, independent variable, dependent variable. And so these go up to 4, so that's not a big deal. Make sure they're equally spaced. 1, 2, 3, 4. Okay, that's your 0. And then these start at 50. So if you wanted to, you could go 10, 20, 30, 40, 50, and you could do that. But notice no one scored below a 50. So if you don't want to start at 0 and go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, which you could easily do, you can do what we call a little zigzag thing, which is like we're cutting the graph. So we're cutting those numbers out, and we're going to start at 50. And that way, maybe we have some more space. So could I do 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100? Okay. So I could maybe do that. So I'm going to go by 55. So I'm going to go by 5s instead. 55, 60, 65, 70, 75, 80, 85, 90, 95, and 100. All right, and that would be like maybe their percent grade, and then it'd be like, I don't know, test scores would be the title or something like that. And so what you would do is at 0, you put a dot at 50. You can't put a dot in the cutoff area. So if you need a dot at 48, you can't do this cutout. 2, I would have 65, I would put a dot, so 2. And at 2, I would have a 75. 3 would be an 88. That's 85. Shoot, go up a little bit, 88. 3 would be a 79, so about right there. 3 would be an 85. Oh, hey, I lucked out. I do want that guy back. And 4 is a 98, so about right there, okay? And so this is not a line graph. A line graph is one that shows like change over time. So maybe I start out weighing 180 pounds, and then I lose weight, and I gain weight, and I lose weight, and I gain more, and then maybe I come down here. Showing change over time is one person or one piece of stock or your blood pressure every minute going up and down, okay? This is different people, and so you're not going to connect them because, like, why would you? They're different people. But you're looking for a general trend. And so when I look at this, I kind of see a general, kind of an average line about right there, okay? And that's called the line of best fit, okay? And we look for a correlation. If this is perfect, okay, so if this is absolutely perfect, and it's going positive, like positive slope, so every point is on my line, like nothing's off it, that would be an R value of a positive 1, okay? If everything's perfect with negative slope, then it is a negative correlation, and R is a -1. So that's if it's perfect positive correlation, meaning as one goes up, the other one goes up, or as one goes down, the other one goes down, right? So maybe the more I exercise, my health index goes up, okay? Something like that. This would be the opposite. As one goes up, the other one goes down. As one goes down, the other one goes up, okay? So maybe the more minutes I spend brushing my teeth every day, the number of cavities I have that year goes down. And again, those are for a bunch of different people. Okay. Now, real life is never perfect. So like this is, you know, sometimes things are on it, sometimes they're not, but it's a general trend. So this would be R is a positive 1. This is a pretty good correlation. So it might be R equals, I don't know, 0.8, maybe R equals 0.9. But we're going to use Desmos to find it exactly. And then Desmos will help us write an equation of that line, which is really cool. All right. So I am going to pause for, well, actually, let me pause and bring up Desmos. Okay, now this is Desmos graphing calculator. So when you type it in Desmos graphing, okay, how you do this is you hit plus and you hit the table. And we're going to enter our data. So we have 0, 2, 2, 3, 3, 3, 4. And then under Y, I'm going to type in my Y values, 50, 65, 75, 88, 79, 85, and 98. Okay. All right, and let's see what else I'm going to do here. All right, so, well, I want to see them, so I'm kind of scrolling here. There we go. I'm just using my mouse to scroll. You could, there's a plus and a minus thing over here too. Let me see if over here there's a plus and minus you can hit too. But all right, I'm just using my mouse. Okay, so there's my line. All right, so I'm going to hit enter. Okay, and then I'm going to come over here. All right. So if you want Desmos to give you all the equation and everything, what you do is you do Y1, because you want it to take all the Y values and write a formula, Y1, and then you use the little tilde key to the left of number 1. Not an equal sign, but the little tilde, it's to the left of number 1. And then you do M, X, again, 1, because you want all these X1 values kind of averaged up, plus B. So if you remember Y equals MX plus B from algebra in high school, that's what we're doing there. Okay, but we're letting the computer do it for us. Okay, so notice the calculator does it for us. Do you see R right there? So this is actually not a positive one, but it's 0.96. That's pretty darn close. So this is a super strong positive correlation. And then down here, do you see it gives me the equation of the line? It tells me M and B. So what I can do is I can take that, and then I could just write the formula. So Y equals, fill in your M. M is what? 12. So 12x plus B is what? 48. So where's my mouse there? 48. Okay. So how does that help me? Well, all right. So say that I think someone is going to study, you know, like 2.5 hours. I could predict what their grade is going to be based on input and output. So I know the input. So I'm going to do 12 times 2.5 plus 48. And I'm going to type it in my calculator here. So I have what? 12 times 2.5 hours plus 48. And I get 78. So I would predict that that person's going to get a 78%. Now, it might not be perfect, right? It's just a prediction. But based on, this is real data. This is my predicted value. So this isn't like for sure. It's just what I'm predicting, okay? All right, and I'm going to write that down and say one other thing on that. So what do we have? Y equals 12x plus 48. Okay, let me get out of Desmos quick and get back to my paper. Just minimize that. There we go. Okay, so in your linear equation, your slope is your rate, and this is your starting amount. That's called your y-intercept. So what that's telling you is if you study 0, you should probably get a 48% because you have some previous knowledge. But every hour you study, you're going to increase your grade by 12%. So if you study 1 hour, you're going to gain 12%, right? 12 times 1 plus 48. If you study 2 hours, you're going to gain the base plus 24%. If you study 3 hours, 48. And again, these are linear. They're not exponential, meaning, you know, they kind of go straight up. All right, let me show you another one here. Say I give you, I don't know, let's see, sometimes in chemistry you might do seconds, and then you might do, I don't know, temperature in degrees Celsius or something. So say at 0 it was 42 degrees Celsius. At 1 second it was 38 degrees Celsius. At maybe the 5-second mark it was 20 degrees Celsius, and maybe at the 8-second mark it was 12 degrees Celsius, and maybe at the 10-second mark, it was 0 degrees Celsius. Okay. All right, so what we're going to do is I'm going to type this in, and we're going to look at it and see what Desmos says as far as the equation. And there is math you can do to do this. I just don't expect you guys to do it by hand. All right, so I'm going to get out of that. I'm going to get out of that. All right, so I'm going to go up here to the plus sign, ARM Desmos, and find the table. Okay, and then I'm going to enter my data. So 0, 1, 5, 8, 10. And then over here, I'm going to enter 42, 38, 20, 12, and 0. All right, so there's that. Okay, so it kind of looks like there's a negative, right? Okay, so I'm going to come down here and you use Y1, not just Y, tilde, M, X1, because you're telling it to use the data from the chart plus B. And notice down here is your R value, so negative 0.99, so almost a negative 1. And then here's your M and B. So if you're going to write a formula for this, let me get my screenshot here quick. Okay, if you were going to write a formula, you would have Y equals negative 4 point, I'm going to round to what, 0.6, I think. Notice the slope's negative because the line's going down, plus, what is that, 41.88, which should be about your starting temp. So again, this is your start, my starting temp, and this is, it's going down about 4 degrees every second. This is your rate. This is called your slope. This is called your y-intercept. Now, I could give you like, okay, what's the temperature going to be after 4 seconds? So if it's 4 seconds, I'm giving you input. You would shove in 4 into this formula, use a calculator, and get output. But the other thing I could do is I could give you output, and you could have to find the input. And that's where you're going to have to remember your algebra. So if I say, okay, when is this going to be 15 degrees? Well, 15 degrees is output, so you're going to put 15 in for output. Where my mouse? 41.88. And then you'd have to subtract 41.88 from both sides and divide. Okay, and I'm going to switch. Let me write that on my sheet here. So we have, we want to know when is it going to be 15, which is output. So I'm going to write that down on my piece of paper so we can look at that. All right, I'm going to get out of there. No, and I'm going to get out of there. I'm going to get in here. Okay, so this is my output. I'm solving for my input. So in algebra, you get rid of the adding and subtracting first. So I'm going to do 15 minus 41.88. Then I'm going to divide. So by whatever's by the x. So I'm going to divide by that. Oopsie. Decimals over there. Okay, so x is approximately 6.62. And again, what's my input? My input is what? Seconds. Okay, so either way, you know, you can put input in here, which is time, do the math to get output, or if you know output, you can put that there, solve algebra to get the input. All right, again, sometimes there's no correlation, you know, so it's like, I don't know whether you have, and again, it has to be 2 numbers. It has to be a scatter plot. So it could be, you know, I don't know, like the temperature outside and how many, I don't know, how many pieces of gum you chew or something, right? If there's no correlation, it's going to look like that, okay? It's just, you know, and if it's exponential, right, like, woo, it's going to look like that. Like linear stuff, you know, all lines up. But if it gets really big, really fast, right, that might be exponential or something along those lines. And again, if you want to, like when you do your My Math Lab homework, if you want to get into Desmos and have it graph your scatter plot, you can. And then if you're looking at the ones on My Math Lab, just make sure you kind of set your window about the same. So if our My Math Lab, it goes from 0 to 40 up to here, you know, kind of do the same. But if it has different units, like bigger units, like maybe 50s, you might need to zoom out. And if it has littler units, I don't know if I can get to them or not. You know, you might have to scroll a little bit to kind of make it fit what you need it to fit. All right, hopefully that helps you. And this is our last section in 12.